Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. We're going to pick up here in 7.2, which follows 7.1 for Math 1316 or 2412, the trigonometry aspects. We've covered the fundamental identities and tried to get used to using them. So now we're going to get into what's really more verifying equivalency proofs, verifying that things are equal. Because there's some aspects here where you get used to being algebraically clever, using the identities. And the good news is you know where you're supposed to end. You know that these two things are going to be equal to each other. It's really about making the bridge to get from one side to the other. So you have a few choices. You can start on one side and work it until you get to the other side. You can start on the other side and work it till you get to the original side. Or the third choice is to work this one until you can work it no more, and then try to get this other one to look like it at the bottom to kind of create a bridge from one side to the other. Generally speaking, your starting strategy should be use the identities. I like to start with the more complicated looking side to get it to more of the simpler side because it's easier to cancel out things than introduce them. That's really step 5. And if you get stuck on one side, try working the other side. And then finally, sometimes you have to consider factoring things out, cleverly multiplying by 1, where you make the numerator and denominator the same, using conjugates, cleverly adding 0. These are all things that will come into play that you might need to use to manipulate one side to look like the other. So let's start with cotangent theta plus 1 equals cosecant times cosine theta plus sine. I'm going to start with the more complicated side, which is the right side, and I'm going to start by distributing. Clearly, there's nothing here that still has things factored out, so I'm going to start by distributing and see if that helps me in any way. So it'll be cosecant theta cosine theta plus cosecant theta sine theta. So that is equal, this one is equal to this. Now I'm going to write my cosecants now as 1 over sine theta times cosine theta plus 1 over sine theta times sine theta, just to see what I know and how I can combine these. So that's equal to that. Multiplying these, this is now cosine theta over sine theta. 1 over sine theta times sine theta means the sines will cancel and leave me with a 1. And then cosine over sine theta can also be written as cotangent theta. And once I'm here, that is the other side. So these are the steps that I really needed to take. I needed to distribute, I needed to multiply my terms together and cancel out the appropriate terms, and then rewrite one of them using a quotient identity. But for the most part, this one wasn't too bad, and a lot of the beginning ones will be pretty easy to handle, but they will get more complicated over time. Now you don't want to do anything like multiply something to the other side. That's one of the things that's really important. When you're doing something to one side, you just work on one side and get it to look like the other side. Don't do the same thing to both sides. This isn't equations that you're trying to balance. We know they're balanced. We just need to show how they are balanced. So there's going to be a lot more of these as we go through. We can start by doing number 2. Tangent t minus cotangent t over sine t cosine t equals secant squared t minus cosecant squared t. So there's a few different ways that we can approach this. You may debate with yourself as to which one is more complicated than the other. I think personally fractions are generally easy to clamp down on than it is to introduce them. So I'm going to start with the left. I'm going to write all of my tangent and cotangent in terms of sine and cosine to see what I'm working with. This is sine t over cosine t for tangent minus cosine t over sine t over sine t cosine t. A lot of sines and cosines. Now I would like to clear both of these denominators because I don't really like fractions inside my fractions. To clear a cosine, I have to multiply by cosine. To clear sine, I have to multiply by sine, which means I need to multiply this by both cosine t and sine of t. In order, though, to not change my equation, anything I do to the numerator, I also have to do to the denominator. So this is going to get distributed to both of these things. And these are all multiplied together, so we'll see what happens. So cosine t sine t, here the cosines will cancel and there will be two sines. So sine squared t. In the second part, the sines will cancel and we'll have two cosines. So sine squared t minus cosine squared t over, and in the denominator, I've just got sine squared t, cosine squared t, because all the sines and cosines will just group together. You might be like, well, how does this help? As a reminder, one of the things that you can do, addition and subtraction, is you can split numerators. Anything that's added or subtracted in the numerator, you can split them into separate fractions. Remember though, that if they're added or subtracted in the denominator, you cannot split fractions that way. So this was equal to this, which is equal to this. Now I'm going to separate it. This is now sine squared t over the whole denominator minus cosine squared t over the whole denominator. And if you look at that, here the sine squared t's will cancel, so I'm going to write it going this way. That'll leave just 1 over cosine squared t minus, here the cosine squared t's will cancel and leave with 1 over sine squared t. And again, since these are equal, this is equal to this, 1 over cosine squared t is secant squared t, 1 over sine squared t is cosecant squared t. That gets us to the other side by creating a bridge. Now what would have had to happen if we started on the other side? We would have chosen to rewrite secant squared t is 1 minus cosine squared t minus 1 minus sine squared t. In order to combine these two fractions, we would have had to get a common denominator so that we can combine them in one fraction. And then once we did that, we would have had to complicatedly turn these into their appropriate party, which would have included multiplying by this or kind of dividing by this, but it wouldn't have been super clear how we did it. Personally, I think it would have been much easier going left to right here than right to left, or at least to see what was going on. Now looking at number 3, these look kind of similar to each other in terms of difficulty. I kind of think that the right side with its complicated denominator is harder to work with than a complicated numerator. Just as a concept, it's not always true, but it tends to be true. But there is one thing that's really important that we're going to start with from the left side just because. Now you'll notice, you see this 1 plus sine x, and you don't see it anywhere here. This is because this one kind of requires a strategy to recognize how you turn a relatively complex denominator into a simple one, and that is multiplying by the conjugate. So the conjugate of 1 minus sine x is 1 plus sine x, and if you multiply both the numerator and denominator by that same thing, and you distribute, you'll get cosine x plus sine x cosine x. In the denominator, 1 minus sine x times 1 plus sine x, and you could have not distributed this, we'll see why here in a second, is the middle terms cancel and you end up with 1 minus sine squared x. Foil if you have to show it, but it's really helpful. The reason this helps us is we know that sine squared x plus cosine squared x equals 1 is one of our fundamental Pythagorean identities, which means if you subtract the sine squared x to the other side, you get cosine squared x equals 1 minus sine squared x, and this is why knowing those identities from the beginning, 7.1, is really, really helpful and how to manipulate them. This allows this thing to turn into a cosine squared x, which is much easier to handle. Now, if you hadn't distributed this cosine, you wouldn't have had to factor this one out. This is cosine x times 1 plus sine x over cosine squared x. This has one cosine that it can cancel out one of them but not the other, and so that leaves you with just a 1 plus sine x over what will be left of just 1 cosine x, which is this other side, and so that makes them equal. And we'll continue to look at more tricks in the next video.